for the reaction. We got 0.06 liters times 0.8 moles per liter. And this gives us 0.048 moles of base. And again, we still have the 0.096 of the moles here. And since we have less of this and this, we're going to subtract 0.048 from this, because that is going to eat up 0.048 of this, to leave you 0.048 moles of the H positive. So go to the chart. Keep going in the wrong direction. This. Alright, and so we're going to put in 0.048 here. The total volume is 0.12 plus 0.06, which is 0.18. Alright, and then we're going to divide the number of moles is 0.048, we said, of the hydrogen. This was the base, this was the acid, this subtracted that from that to give us the H positive. Now to find the concentration, we'll take 0.048 divided by 0.18, and we get 0.267 moles per liter of H positive. And again, negative log of that, round off the 2 decimal places, 0.57. So there's a slow uptick in pH, but not a dramatic change. So, but we're going to continue going on here. All right, so we got 0.08 liters next. So we got 0.08 liters times 0.800 moles per liter, and this is 0.064 moles of hydroxide, sodium hydroxide, and we got 0.096 moles of acid. Again, we're going to eat up all of that, and it's going to take out 0.064 moles here to leave us 0.032 moles of H positive. So when these two get done reacting, we still have an excess of H positive, but it keeps getting less and less each time because we keep getting more and more base working against it. And did it again, keep going the wrong direction. So this is going to give us then, we said that the base for this was 0.032, no we didn't. We said it was 0.064, and then the total volume is 0.8 plus 0.12, which is 0.20. The moles of excess was what we got when we subtracted that, and that was the 0.032 moles of H positive. And I don't have to put moles in here because I got that in the title of this column. Now I'm going to divide those out. This moles by this liters gives me 0.16 moles per liter of H positive, and the negative log of that is 0.80. Okay, so we added 20 milliliters here, it went up by 0.14. We added 20 milliliters here, it went up by 0.23. So we can see that there is this is not going to be a straight line graph when we make the graph of this. It's actually going to be what we call a logarithmic curve. But we will continue here. Next we'll go to point 10. So we have, down, 0.10 liters times 0.800 moles per liter. That gives you 0.8 moles. Liters cancel out. This is still 0.096 moles of H positive. This is OH negative. This is going to be, again, this is not as much as this over here, but it's going to take out a huge chunk, 0.08, and it's going to leave us 0.016 moles of H positive left over. Okay? So, we put that information in over here. Again, in the wrong direction because I'm an idiot. All right, so here we go. So this is going to give us 0.08 here. The sum of these two right here, 0.12 and 0.10 is 0.22 liters. The moles of excess we said is 0.016 on the H positive. Divide that by 0.22, and I get 0.0727 moles per liter of hydrogen. Then I take the negative log of that, and that turns out to be 1.14. Okay, and so now between these two, I've added 20 more milliliters, and it went up by 0.34. It had gone up 0.23 here, and it got up 0.14 here. So that in the consistent changes in the amount of base that we've added to the beaker, the pH starts to get bigger and bigger and bigger. Like I said, it's not bigger and bigger and bigger in a linear sense. It gets bigger and bigger and bigger, and the size of the beaker gets greater. So I don't know if that makes any sense to you, but in logarithmic terms, it makes a huge amount of sense. This is a key point. Now, so before I do this one, I want us to understand that there's actually 4 stages of titrations. This right here is the first stage, and I'll enumerate this later on, but this is where no titrant has been added, no base has been added. And so that's the first stage. These 4 represent the second stage, and that's where there's more acid than there is base. And every time that happens, we get these small increases in pH, but still more acid than base, and that's why we get a pH that is as low as it is. Next, we have 12. We have 120 milliliters, which is 0.12 liters, times 0.8. And that gives us 0.096 moles of hydroxide. This is 0.096 moles of hydrogen. And it looks like they cancel each other completely out, which technically they do, but there's one issue here. If there is no hydrogen ions and no hydroxide ions, then we wouldn't be able to find a pH. There is actually a concentration, but it looks like 0 moles of hydrogen and 0 moles of hydroxide. However, because these are found in water, there is really 7 times 10 to the negative, 1 times 10 to the negative 7 moles per liter of hydrogen, and 1 times 10 to the negative 7 moles per liter of hydroxide. Why, you may ask? Well, it's because of Kw. We talked about this when we found pHs and how to come up with that. We said there's something called Kw, which is the concentration of hydrogen times the concentration of hydroxide. It is an equilibrium system because water doesn't break down completely. It's a double arrow dissociation reaction. And we found that the value of Kw is 1 times 10 to the negative 14, which means these two have to be the quantities here to give us that value. So we're going to look at this. We're going to put this on the chart to explain where our pH came from. And again, I go the wrong way because I am so stupido. So we got the moles here we said was 0.096. We have 0.24 liters because 0.12 and 0.12 is 0.24. Moles of excess, 0. We'll just put the 0 there for anything. But the excess concentration that we're going to look at for the pH is 1 times 10 to the negative 7 moles per liter, which is 7.00. Take the negative log of that. And that's why we put that in there. Now we could put 0 there and understand that it means that there's no excess, which is technically correct. But to explain where the 7 comes from, we really should put that in there. Okay? So now, we have, that is stage 3 right there. That's where the concentration of acid and base are identical. And like I said, I'll list this out pretty soon here. We come back to the calculation for this one, 0.14 liters.